Alright, hi again. Now it's time for the last video here about creating some math art using transformations of functions. In the first video we learned about how to create an initial form to serve as the base of the artwork. In the most recent video we talked about applying functions to create sequences that allow us to modify the initial form through function transformations. In this video, what we're going to do is we're going to kick it up a notch and apply multiple transformations to the initial form at the same time. That's going to allow us to put in a whole extra level of dynamicism to our piece of art. Alright, so what we did in this previous setup is we modified one parameter using the functional approach. And we're going to use that same technique to modify multiple parameters at the same time. Alright, so let's say what we've done now is we've changed the parameter A, which was this the vertical stretching and shrinking. Let's say we wanted to transform this piece with a vertical shift at the same time. Alright, so we have to ask the same questions that we did before. What parameter is it that does a vertical shift, and what range of values do we want it to take on? So from our initial function, which was up above, from our initial function, the vertical shift is k. That moves things up and down. So what we're going to do is we're going to move k at the same time as we move a. And so that's going to make an interesting shape by doing that. So what we want to do is we want to modify k. Alright, and what values of k? Well, here we were at -2. What if we move it all the way up to 3 at the same time? Alright, so what that means, we're going to come up with a new function. So we're going to create a linear function that we're going to call r of x. R of x. And what do we need it to do? We need it to start out at -2 when n is equal to 0 and go up to 3 when n is equal to 20. That's giving us a slope of 5/20 times x, and the vertical, the y-intercept of this function is what the function is at 0, which is exactly -2. So here's our line in the form y equals mx plus b. And this is now the k value that we had before. So let's take our function. This is not this. I want the function from last time, where we had this y is equal to this. New expression. We have y is equal to this equation. And what we're doing is we're changing this value to be the vertical shift. And so we're going to replace this -2. Let me get rid of the blue line so we can see what happens. We're going to replace this -2 by plus r of n. And what do we get? We get this first one and the next one, they open gradually, and the one at the top is higher than the one at the bottom. If we wanted to, we could change this so they're all kind of the ones at the top. We're now, the vertical shift is going downwards instead of upward, and you start to get some moire type of pattern. Let me put this back the way it was, and let me suggest at the same time we can replace, so what did we do? We did a vertical shift at the same time as the vertical stretch. Now you could also do a horizontal shift at the same time. So let's create a function for the horizontal shift. What if we chose q of x to be negative x over 40 plus 2? I mean, these are things you're going to play around with, and you're going to see what you can do with them. So, new expression. So let me take these ones out. Let me get rid of some of these extra things that we don't need around. And let's now, what we're going to do is we're going to take this y function and let's replace the 2. So this is the horizontal shift is the 2 here, and we're going to replace that by q of x. Q of n. Sorry, q of n. And now, every time it moves up, it also moves over. I guess it's this way. Another thing you can do is change the bounds, the domain bounds. So let's create some new things. So what if we, so here we have this function -4. -4 represents the left bound of our piece, and this -1 represents the right bound of the piece. So let's create functions that modify those at the same time. So we have maybe p of x for the left bound, o of x for the right bound, and then we create a function. So we take this y equals, let's get rid of the green ones, and let's post this where we change the -4 to be p of x, and the p of n, and the right bound to be o of n. All right, and so what we're doing is we are changing the position, we're changing the slice, where the slice happens, where we're restricting the domain, and that's going to be different for each of these different transformations. So you can see that we've added a whole extra level of the dynamicism to the transformations by doing multiple transformations at the same time, and also changing the domain of the function at the same time. All right, so let's stop there for now. Time for you to go play, see what you can do. All of these techniques will apply no matter what parent function you have, no matter what transformation you decide to do. So give it a try, see what you can come up with. All right, take care. Bye.